Very much, Rajan. Hello everyone, I would like to welcome you to my presentation. The topic seems to be more like geotechnical, but in fact later on I will discuss the design aspect and what challenges you can face in the design of underground tunneling. So the primary aim of this research was to analyze in detail the factors which are involved in the settlement criteria for the underground tunneling, and thus how those settlement and the final stresses can impact on the final design. So before proceeding further, here is a brief introduction, overview of the presentation. And the ground deformation due to underground tunneling has many factors involved, and still it's a debatable topic. But there are four major factors which we have to consider, such as the construction method. We have the Neo-Austrian tunneling method or the bore tunneling, and we have several others as well. Then what type of ground deformation can occur, and the analysis approach. Nowadays we have more sophisticated computer application tools which we can mobilize to get these ground deformation, and finally the tunnel lining design approach. So here is in figure number 1, this is a 3D settlement profile in both longitudinal settlements as transverse as well. And in figure 2, we can see the schematic illustration of the forces which are acting on the tunnel linings. So in 1969, Ralph Peck, one of the big names in the geotechnical engineer, presented an idea that the soil profile looks like similar to the causing settlement curve. So we have these two equations to establish the soil profile. So in equation 1, one of the major components is the maximum settlement which occurs at the ground surface. And then in order to calculate that maximum settlements, the volume loss and of course the inflection point need to be considered. So the volume loss still is we can say that very difficult to analyze that before even starting of the project, that how this volume loss can be considered. But there are, because there are a number of factors involved itself in the volume loss. As you can see, there are 4 different factors. And in fact, as a starting point, Ahmad and Iskandar in their research paper, they have well defined some starting points for different type of ground conditions which volume losses can be considered. And also you can find the detailed volume loss analysis in our published paper, and every equation has been defined over there that how such equations can be utilized. So similarly, inflection point is by Baer and Taylor is defined in equation 3. It's toe width parameter times the tunnel depth, which is applicable for the homogeneous ground. And there are certain values which are given over here for cohesive soil as a K-mean value 0.5 and cohesion soil as 0.35. Now, other than that, there are several other equations which later on I am going to highlight that how this inflection point can affect the maximum settlement point as well, which occurs at the ground surface. So coming to the methodology, I have employed a finite element model, and approximately 1,600 models were simulated based on the different soil types and different tunneling parameters they are considered. And we have employed the Moore-Coulomb model for the material properties, because we selected some of the points from we selected our parameters from the some tunnel case studies. So these are the input properties for the finite element software and the lining properties. So it was a 3-stage analysis. The first stage was the initial effective stresses were generated based on the KO method. And then in the second stage, the installation of the tunnel lining. And in the final stage, the removal of soil inside the tunnel premises, and a uniform contraction method was applied. So here are the volume loss variations at the right side and the tunneling length variations. So in results and discussion part, here is the soil profile at different one of the specific parameter for the tunnel lining, and we have a soil profile. And then in the second figure, we have the maximum settlement points we selected at the ground surface, and then the inflection point. And based on all these analysis extraction, the ones we took We have in figure 9 the variation for the volume loss in terms of the settlement, so it's linearly related. Whereas when diameter to depth ratio, which is in the right side, it's non-linear relation over there as observed. So if we combine these two effects, we modified the original equations based on the volume loss and the diameter to depth ratio, and the inflection point somehow omitted by replacing them with the fixed fitting coefficients over there. So these are the fitting coefficients for different type of the soils which can be employed. Similarly, detailed analysis for the inflection point as well was carried out. For the volume loss, we found out that there is no significant relation. One of the major cases is that the diameter in fact has a big influence, especially when it comes to the lower depth, shallow depths of the tunnel. And we have established a linear relation based on our observation, and the fitting coefficients are provided in table number 6. So we have validated our equation, modified equation with the field data, and overall the performance was quite well. Approximately 18% error was just obtained. And if you consider the many variations which are involved in the strata and other aspects. But in the beginning, I was mentioning that the inflection point equations can have a significant impact. And if you see the figure number 15 on the right hand side, I have substituted all those table number 3 equations, and we can see that in major cases the maximum settlement was quite underestimated, which can be which we have to avoid in such aspects, because tunneling projects includes many sophistications and many complications. So our equation has, which is the modified equation, has shown a good performance, and when we see that we compare the inflection point between each study, we can see that how they are varying, and this is one of the fundamental aspects why the settlement values were quite high. So this is in this table is the back analysis chart for volume loss. So this can be quite helpful for the practicing engineers that and as initial guidance. So on the extreme left hand side, we have some our equation, and for the back analysis, our overall performance shows that it is the VL reference which can be calculated beforehand can be quite similar. Whereas if anyone wants to, for example, prefers other equations, it can be a guidance that either higher volume losses should be considered or lower volume losses. So then, of course, we have to design our tunnel. So we have there, according to the International Tunnel Association (ITA), there are like basic assumptions we have to consider. That the cross section is in plane strain condition of the tunnel. Then we have our cross section as a circular, and the soil stresses are generally assumed as equivalent to the initial stresses. And of course, what type of bond is between the tunnel lining and the ground. So there, I will only specify 3 basic models here. I have a basic model which is suggested by the Baker in 2003, analytical model, and the continuum method. So in basic model, only the initial stresses are considered, and the soil structure interaction is not considered in that model. So one of the drawbacks of that model is that it generally assumes very high axial forces and bending moment diagrams when it comes to the final design of the tunnel lines. So here, like I would like to highlight here is that how, for example, the tunnel lining stresses can vary. So in this case, if you see over here, if I specify one of the examples, these are the initial stresses, and as the volume of loss increases, there will be some certain stress relaxations. So in
I'm sorry, just 1 minute.
So in generally for the stress relaxation, in cohesive soils it occurs like after a long period of time. So it's better to always, for example, plot a kind of a design chart that how, with the help of volume loss variation, what can be the stress variation as well with time. So these need to be considered in such design elements. So as previously discussed that at shallow tunnels, how the axial forces in the top chart can, for example, differ from the other methods. So in this case, the researchers have mentioned that we should create a kind of like upper and lower boundary limits, so that we can monitor along with the field monitoring that how the stresses are changing with time. So finally, I will conclude my presentation. So in this presentation, I highlighted different aspects which involve in the settlement criteria of the underground tunneling, how the inflection point and the volume losses can greatly affect, as these two are mostly dependent on the geological characters of the site. And thirdly, we modified the original equation in this aspect, and the overall performance showed a good result. And finally, some stress relaxation and how the stress relaxation and the lining forces can play a crucial role in the tunnel linings. Thank you very much.
This was the last technical presentation for this